Hey guys, it's Mary and welcome back to Study Journey. Welcome back to the Python series. This is episode 4 of the Recursion Problem Set series, and in this episode we're going to be finishing off what we did in the previous episode on the first part of Caesar Cipher, and we're actually going to build the shift dictionary and also apply it. So without further ado, let's get into the video. Okay, so in the previous video we talked about the part 1 of message. So now we're going to finish this by talking about build shift dict and then also apply shift. So it says right here that build shift dict creates a dictionary that can be used to apply a cipher to a letter. And the dictionary maps every uppercase and lowercase letter to a character shifted down the alphabet by the input shift. And the dictionary should have 52 keys of all of the uppercase letters and all of the lowercase letters only. And when we are shifting, the amount to shift every letter of the alphabet is between 0 to 26, because there are 26 letters in the alphabet, and we can't shift more than that, or else it goes back to the beginning. And the result of this function should return a dictionary mapping a letter to another letter. And so we're trying to create the shift right here. So let's first dictate the shift to be an empty dictionary. And then now, so for every character in the alphabet, we're going to create the shift and see how we're going to order it. So first, for every letter or character in the alphabet, so A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. We have to type out the whole alphabet. For every single letter in here, we're going to define the shifted character and set that to looking at the set. First, we're going to look at the order of the character minus where the beginning is, so A. And then we're going to add it to the shift. And then this whole thing we're going to divide it by 26 to make sure it is within 0 to 26. And we're going to use the percent number because this makes it, and then the answer is a whole number after the division. And then we're going to add this to the beginning. So basically this is saying, what is the shift starting from the letter A. Alright, now that we have that, we're going to be updating the shift dictionary to contain the characters and then set that to shifted characters. So this is how much it is shifted. And then from there, we're going to let the uppercase equal the uppercase, and then the lowercase be the lowercase. So shift dict, and then with the characters when they're uppercase, it is going to be the same as the shifted characters when they are uppercase. Because right now, this is all lowercase, so we have to make sure that the amount for the shift of the uppercase and the lowercase are basically in here the same. And then as it says, this thing will return a dictionary mapping a letter to another letter, which is the shift dictionary. Okay, so now that we have this, we have just finished the first part, which is building the dictionary. And now that we have built this dictionary, we know what it looks like. And basically, it is just a letter mapping a single letter to another letter by the shifted number that the user will give it. And now we're going to apply the shift. So in this function, we're going to apply the Caesar cipher to self.message text with the input shift. So this is going to create a new string that is self.message_text shifted down the alphabet by some number of characters determined by the input shift. And then, so the shift is going to be an integer, so it's going to be a number between 0 and 26. And when the user inputs that, we're going to create the new text that is going to be the letters shifted down by how many ever number that the user input. And this is going to return the message in which every letter is already shifted down the alphabet by the input shift. So let's get everything ready. And the first thing we're going to do is first define the shifts dictionary. And then we have to initiate it with the self. And then it's going to be build shift dict, and then with the shift in place. Now for the final shifted text, we don't know what it is yet, but I'm going to set it because we know it is going to be a string. Okay, and then now that we have this, we're going to actually implement the Caesar cipher. So how this works is for every character, so for character in the message text, self.message text, if it is an alphabet, then we're going to shift it. If it is not, then we don't shift it and we keep it the same. So remember, in the Caesar cipher, we're only changing the letters, whether it is uppercase or lowercase. We're not changing any punctuation or any spaces. So if this character is alpha, which is an alphabet, then we're going to apply the shifted text to be the shifted text plus shift underscore dict character. And then otherwise, so if it is not an alphabet or a letter, then we're going to update the shifted text to just be the shifted text plus the character. And then finally, we're going to return the shifted text. So in the beginning, we're dictating the shift dictionary, so how much we shift it. And then here is the shifted text that we don't know yet. But in the end, we return the shifted text by applying this. So for every character in the message, if it is an alphabet, then the shifted text is going to contain the shifted text plus how much is shifted. And then otherwise the shifted text is just going to be the shifted text plus whatever character that we were just given that wasn't a letter. And now that we have this, we have just defined build shift dict and also apply shift. So we built a dictionary that can be used to apply a cipher to a letter, and then we actually applied the Caesar cipher in this apply function right here. So in this episode, we have just finished the first part, which is message, and we have filled in all of the methods of the message class. So all of this right here was in the class message, and we just defined various attributes. And now that that is done, in the next episode, we're going to be moving on to part 2, which is plain text message, and that is below right here. And as we can see, this is a different class. So these are the various classes that we are using in this problem. And so the first one we just did was message, and now we're going to be moving on to another class in the next episode.